Review, Unit 345, number 12. A baseball is hit into the air by the Blue Jays batting coach. Its height, h, in meters after t seconds is h equals negative 4.9 times t minus 28, or 2.8 squared plus 39. A, how high off the ground was the ball when it was hit? So how high was it when it was hit? Now initially I was going to say, well, you need the c value in if we had y equals ax squared plus bx plus c, but we don't. This is in vertex form, so this is actually giving me the vertex 2.8 and 39. So how high was it when it was hit? That means that the time would equal 0. So I need to find the h value when time equals 0. So I'm going to substitute t equals 0 into this equation and solve for h. So how high was it when it was hit? I had to put t equals 0 into this formula. So h equals negative 4.9. There's the t equals 0 minus 2.8 all squared plus 39. Put it into my calculator and I get that the height when it was hit was 0.584 meters. So the maximum height of the ball occurs at the vertex. So we need to know the vertex. And since this is in vertex form, we can pull the vertex right out of there. So it's 2.8 and 39. Now that means 2.8 seconds and 39 meters. So the height of the ball the maximum height of the ball is 39. Okay, so now they want to know the height after the 2.5 seconds. So that would mean t equals 2.5 seconds. I can put 2.5 seconds into this formula and find the height at that point in time. It's also asking whether it's on the way up or down. Because the maximum occurs at 2.8 and 2.5 is before that, it's on its way up. So the height after 2.5 seconds, I put 2.5 into the original equation and I end up with 38.559 meters. And it is definitely on its way up because, like I said, the 2.5 happens before the maximum at 2.8, so it's on its way up. The next question asks, when does the ball hit the ground? So I know the maximum from this vertex form. To get when it hits the ground, that's a 0, so then I guess I need factored form, so I could expand this and try and factor it. With these decimals, I'm suggesting that perhaps factoring might be too tough. So when I get this expanded into ax squared plus bx plus c, I can actually use the quadratic formula with the a, b, and c. So I think that's my plan. I'm going to expand all of this to get ax squared plus bx plus c and then use the formula. Okay, so t minus 2.8 squared means there are two of them. So in the next line, I've used the distributive property to expand that. Use the red arrows and then the red print to show you what the red arrows gave me using the distributive property. I simplified what that was, and I get t squared minus 5.6t plus 7.84. Then I use the yellow arrows to distribute the negative 4.9 through this bracket, but not including the plus 39 because that's on the outside. And then the yellow print is to show you what's happened with the yellow arrows. So finally I get in standard form this equation. Now to find the zeros, I can use the quadratic formula. Okay, so we rearranged into standard form. We use standard form and the A, B, C with using the quadratic formula, plugging it in, solving that through, and I end up with negative 0.0212 and 5.621. Now I did a little sketch here. We know that our vertex is at 2.8 seconds with 39 meters, and that would be the axis of symmetry. The zeros would be on either side, like equidistant apart. The 1 0 we see is over here at negative 0.0212. And since we're talking about time and height, and time can't be negative, then we're going to ignore this 0. The other 0 happens at 5.621, so the ball hit the ground at 5.621 seconds.